Many people actually think that algebra is all about letters. When they see letters like X and Y, their brain just scrambles and shuts down. But you're getting the wrong idea. Algebra is not all about letters. It's actually just like a detective game, for instance, where the numbers are disguising themselves with masks that are the letters that you see in algebra. And you only win the game when you are able to reveal the identity of the numbers. So this right here is a scale. In one part of the scale, we have a mystery box with 3 apples, while on the other side, we have 10 apples. And these two sides of the scale, they actually weigh the same. But there are amounts of apple that is in this mystery box. The question is, how many apples do you think is inside this mystery box, given that the weight on the right hand side is equal to the weight on the left hand side? You don't need to have a PhD to know that inside this mystery box contains 7 apples, because when you have 7 apples plus 3, it becomes 10 apples on the left and 10 apples on the right, which is why they have the same weight. So you have actually done or performed algebra without breaking a sweat. The problem with school is that they skip this illustration entirely and they go straight to this, and it becomes another language entirely. My goal is to teach you that language fluently, that you stop seeing scary equations and start seeing puzzles that are begging to be solved. In the next 10 minutes, we're going to cover the golden rule of equations, why inverse is just a fancy word for undo, and how to solve for x every single time without breaking a sweat. If you have ever felt bad at math, stay with me, because you're about to realize you've been doing algebra your whole life. Alright, so let's talk about the golden rule. Well, there's something that I will tell you that the golden rule is not. The golden rule is not any complex physics law or theorem out there. It's actually quite simple. And this is what it states: that whatever you do one side of an equation, you must do the same thing on the other side of the equation. That is it. That's the golden rule. So what does this mean? Let's go for an illustration, shall we? Now, let's assume that the equality sign is the center point of a balanced scale. Now, we have on the left hand side 10 pounds of weight, and we have on the right hand side 10 pounds of weight. What happens when you have equal weight on a balanced scale? The balanced scale is, well, balanced. So now what happens if I add an extra 2 pounds to the left hand side of the scale? Your guess is as good as mine. The left hand side of the scale slams down. Why? Because the weight there is heavier than the weight on the right hand side of the equation. So this equation, or rather the scale, whichever you want to call it, is not balanced. So what must I do to balance or even the scale? To balance or even the scale, I must also add 2 extra pounds on the right hand side of the equation, and the equation becomes balanced. This is the concept of algebra. Alrighty, so let's look at this number. X plus 5 equal to 12. Now, using your brain, you already know that x is equal to 7, because 7 plus 5 is 12. Cool. But now the question is, how do we formally represent this? How do we do this in the formal way? Now, if you take a look at the equation, you'll realize that plus 5 is standing on the way, right? And the aim is to get x to stand on its own. So what do we do to get x to stand on its own? We have to eliminate this plus 5 here. Then x will stand on its own. But how do we do it? We do it by subtracting, or rather by doing the opposite. And what do I mean by doing the opposite? We have plus 5 here. So for us to get rid of plus 5, we must subtract 5. So what we have is x plus 5 minus 5 equals to 12. But there's something we must understand. Let's not forget that we have what we call the golden rule. Now, if you just do this way, what you will have is, of course, 5 minus 5, it cancels out. So you have x, which you have succeeded in doing, to stand alone. But x is now equal to 12. Hey, what gives? But we thought we said that x is equal to 7. So that means that there is something wrong somewhere. And what is wrong? That is where the golden rule comes to play. Remember what we said about the golden rule? It says that whatever we do in one side of the equation, we must do it on the other side of the equation. So we just don't subtract 5 from the left hand side alone, but we must subtract 5 also from the right hand side. So what do we have? Plus 5 cancels out, minus 5, we have 0. So x is equal to 12 minus 5. And so x is equal to 7. What do you know? Just like what we got here in the first place. So this is why the balancing of equation, or the golden rule, is very, very important when we are trying to solve algebra. And so the scale is leveled again. Now, it doesn't matter if you add, subtract, multiply, or divide. Once you make sure that whatever you do do one side, you do to the other, you can never get the logic wrong. The equal sign is a promise of balance, so don't break it. All right, so we know that we have to keep the scale balanced, but what if x is stuck inside a bunch of numbers? How do we get it out so it stands alone? In maths, every action has a perfect opposite or an inverse that deletes it. Very, very important statement. I must repeat it. In mathematics, every action has a perfect opposite or inverse that deletes it. So the next table you're going to see right now is each sign with its inverse. So here we go. So we have the signs or the actions, and we have the inverse of each action. So the inverse for addition is subtraction. The inverse of subtraction is addition. The inverse of multiplication is division. And the inverse of division or the undo is multiplication. It's kind of like a video game. If your character walks forward, the undo is to walk backwards. If algebra adds 10 to your x, you subtract 10 to get back to the start. So another word for inverse is undo. Okay, so this is where many people usually trip up. Let's look at this, for instance. So we have 3x equal to 15. Now, many people will rush and try to subtract 3 from both sides, like doing something like this: 3x minus 3 equal to 15 minus 3. But then there is a problem. If you haven't seen it yet, let me show you. A letter, or rather a number, is attached to the letter. This number has a letter attached to it. So x is not just alone, but x has a number attached to it, and you cannot remove that number by just subtracting both sides from 3. So that is where the problem lies. So the question is, what do we do? How do we get rid of this infectious disease from x called 3? Now, there are certain things you need to take note of. You need to take note that whenever a number is attached to a letter, they are multiplying. So this means that 3x is actually 3 times x. This number is multiplying with this letter. So whenever you see a number attached to a letter or a letter attached to a number, that number is multiplying with that letter, or that letter is multiplying with that number. Now, this leads us to the undo method. So when we go back to our table, we will realize that to undo multiplication, we must use division. So what does that mean in our algebraic problem that we're solving here? It means that since 3 is multiplying x, then we need to divide 3x by 3, which is the opposite of multiplication. And of course, don't forget the golden rule: whatever you do to one side, you must do it on the other side. So we will divide both sides by 3. So we have 3x over 3 equal to 15 over 3. So 3 cancels out here. So we have x equal to 15 over 3, which is equal to 5. So that means that x is equal to 5. We just undid the multiplication to find the truth. And now we are at the final boss. What happens when x isn't just hiding behind one number, but 2? Take a look at this, for instance. We have 2x plus 4 equals to 12. We have a multiplication that is being multiplied by 2, and we have an addition that is 4 being added. Which one do we undo first? If you pick the wrong one, math gets messy fast. So this is the analogy I want us to use. Imagine you're preparing to go to school. You put on your socks and then your shoes, right? When you get back in the evening, you want to get to your feet. Now let's, for instance, say that your feet is X. You can't take off your socks first and then your shoes. Your shoes are on the way. So you have to reverse the order. When you started, you wore your socks, then your shoes. Now that you want to take them all off, you start with your shoes first and then your socks. In algebra, the number touching the x first is like the socks. The number added or subtracted at the end is like the shoes. To solve for x, we undo the shoes first. So the first step is to subtract 4 from both sides. So we do this. 2x plus 4 minus 4 is equal to 12 minus 4. So 4 cancels out here. So we have 2x equal to 12 minus 4. So 2x is equal to, what is 12 minus 4? 8. So 2x is equal to 8. So we have taken off our shoes. Now it remains the socks. And what is the socks? The socks here is 2. So what do? Since 2x, remember, is the same thing as 2 times x, and the undo of x is divide. So we must divide both sides by 2. So that is 2x over 2 equal to 8 over 2. So 2 cancels out here. So x is equal to 8 over 2. 2 into 2 is 1. 2 goes into 8 4 times. So therefore x is equal to 4. Shoes off, sock off, x is bare. You just solved a 2-step equation. Once you see the layers and what is happening to x, you just peel them back in reverse order until the mystery is solved. If you followed along today, you've officially mastered the core of algebra. But math is a muscle. You have to use it. Here is your challenge problem. Drop your answer in the comments. I'll be hearting the correct ones and helping out if anyone gets stuck. Don't forget to hit subscribe if you want to make math the easiest part of your day. I will see you in the next lesson.